and the examples that I ready. Logarithmic functions. Exponential and logarithmic functions are called inverse functions because the x and y variables switch. The domain of one becomes the range of the other. And I'm not going to focus on this too much, but I thought I would throw that in there at least so you would understand, you would at least know that there's a relationship there. The expression log of x is known as the common logarithm. Okay? The log is common and it's base 10. Okay? I'll try to explain that in a little bit. The expression ln of x is known as the natural log. That's the most commonly used, and our calculator actually only is able to do a regression using the natural log. And it is expressed as a base of e, right, which is Euler's number. The graph never crosses the y-axis. Never does. And here's my, I like Desmos for this. Brings it alive. So here it is. Yeah, go ahead. I thought you were going to teach us about logarithmic, but maybe next time. All right, so if you look at either this logarithmic or this natural log, they're basically, the shape is going to be identical. There's just slight variation of steepness, but that is not the point. But we want to look at what A and B, what do they do to the graph? That's what I want you to look at right now. So I'm going to try to zoom in a little bit. And notice that I typed in A plus B log of X, but there's A plus B natural log of X. Watch, I'm going to graph them both. One is just slightly different shape than the other one, but really the characteristics, everything is exactly the same. It's identical, right? So I'm going to turn that natural log off for now, but just focus on if we were to change the value of A, that first value there, what happens to the curve? I'm going to zoom out a little bit. It drops, and then when it goes up, right, the whole curve kind of goes up again. But even better, watch what I'm going to do. I'm going to enable the point 1A, okay? So let's pause it at any time here. Pause it. So if I were to actually label that, it is 1, -3, which is the value right now of A. Let's keep going. See how it matches the A value? So that is a point on the graph every single time. It's 1A is a point on the graph every single time. Before, you were used to what? Exponential is what? 0A, right? And now it's 1A. That's always going to be a point on your graph. Okay? The next thing I want you to look at is what happens when we change the value of B, which is right, that value right there. What happens to it? Right now it's negative. Focus on that. And if you go from left to right, it is actually decreasing. Okay? So let's keep changing that. So it's still decreasing, and there it turns into an increasing function as it's positive, right? Yes, it affects the steepness as well, but we're just going to focus on whether it's negative, there it drops, right? Or if it's positive, right? If it's positive, it increases. So that's what the value of B will tell us, okay? Whether it's increasing or decreasing, just like before, by the way, for exponential. And the value of A tells us, right, it actually, we can hone in on that 1.1A, but it actually raises or lowers the graph entirely. Okay. Let's look at natural log. It's the same thing. I'm going to turn on natural log here. And if I were to change the value of A, it's still going to look exactly like a logarithmic function. And B still does the same thing. It turns it from decreasing to increasing as we change it, okay? So there you have it. Let's keep going here. the most important part. You ready for this? Wake up, wake up, wake up. This is the one I wanna. It will never cross the y-axis. So the other one was never crosses the x-axis. It will never cross the y-axis. It doesn't matter how much you zoom in. You can zoom in here, right? It looks like it's touching, but the more we zoom in, you can tell it's not touching. So if you keep going lower, come on, come on, come on. At some point you will, right? You think it will touch. And then it looks like it will again. If we zoom in further, there's always going to be a gap. It's never going to touch the y-axis. Never, okay? Which is a bit of a limitation to for modeling things, okay? And I always tell students, the logarithmic, if I zoom out, let me zoom out to the original. Logarithmic is used for, you ready for this? Modeling growth that kind of stalls after a while. Like people, right? We grow, we grow, we grow, but at some point you kind of stall, right? Like it stops. Or trees, vegetation, population. Like right now, planet Earth is going exponential. But at some point, you would think that it has to flatten, right? Because there's only so much room, so many resources, all of these things. Maybe at some point we might have to use logarithmic instead of exponential, okay? So that's when logarithmic is used most often for something that kind of plateaus, right? Because if you zoom out, look at this curve, it kind of looks like a straight line, almost like a constant after a while. So that's why logarithmics are used for certain scenarios, not always just exponential. Think about it. If we were to flip this, you ready? Exponentials usually look like this, right? Exponential either increases. We were focusing on the positive quadrant, right, for word problems, but we started here and it went like that. Or it decreased, right? We started up here and it went down like that. In this case, we're starting, because this is not a word problem, right? And logarithmic basically flipped that. That's why it's called the inverse. It flips the whole thing. And so we have something like this, right? Either increasing or decreasing. Okay? You want to, I don't know, to me it's easier to see if this is highlighted, right? But nonetheless, there it is. So it's very important to remember the graph never crosses the y-axis, right? Both log of x and natural log of x do have the same properties, but when graphed are slightly different. A logarithmic equation has a general form of, so these you need to have on your study. I would have this on my study sheet. You don't have to have both of them. Either one of them is fine because they behave the same way. We focus on A and B. So what does A do? A for both of them is right here, right? You get that point on the graph every single time. You can bank on it, just like you could with an exponential. We went 0A, that was a point on there every single time. For these ones, it's 1A. Okay? I don't want to put it on the graph, but anyways. And what does B do for us? B determines, right, if the graph is increasing or decreasing. That's what B does. That's what B tells us. I would highlight the G-bus out of this, right, just to make sure you understand. Even on my study sheet, I would. Right? So A tells us a point. B, and you know what? You can make the conclusion that A will raise or lower the whole graph. That's another thing you observed, right? But I just want you to, I really want you to remember this. Always include, right? You always want to include that on your graph. Make it nice and big, okay? Watch this. If B is greater than 0, you have yourselves an increasing function. If B is less than 0, you have a decreasing function. So you can actually write, if you prefer, if it's positive, right? If B is positive or negative, that's what we're focusing on here. Not whether it's bigger than 1 or less than 1. That's something you need to remember, okay? I think characteristics of logarithmics. So go down to that box. For both increasing and decreasing functions, the following is true. The end behavior is always quadrant 1 to 4. Watch, right? Quadrant 1 to 4. You want to write that down here? Quadrant 1, and quadrant 4. Quadrant 1 and quadrant 4. Okay? So the end behavior, no matter if it's increasing, decreasing, those are the two quadrants that it will find itself in. Okay? The end points. Can we do arrowheads? It bothers me when there are no arrowheads. Because technically you should have arrowheads, even on the axes, right? But I actually just, I told you, right? Like I'm kind of rushing through these booklets for you to have something, and I hope you appreciate that. So that's why those details don't make it on there. I wouldn't be able to have it in time. X-intercepts, logarithmic functions, right? They cross. These ones do cross the x-axis, and therefore we'll have one x-intercept, not x-intercepts. Sorry about that. Okay. Y-intercept, they never cross the y-axis, so no x-intercept. So it's exactly the opposite. Oh, you see the typo? What is it supposed to say here? No y-intercept. Good thing we intercepted that. No y-intercepts. This is exactly opposite. If you go back to exponential, there's this exact same box, and I just copy pasted it and changed. I changed these two. Okay. Domain would be x is, sorry, I'm mixing it up. Let's just do this one. Domain is 0 because it never touches it to infinity. Right? It never touches the y-axis, so you can't include 0 in your domain. You cannot. The range would be y belongs to all real numbers, like this, or you can go negative infinity to positive infinity. The domain 0 is not included, so you have to, this is wrong, right? This has to be, particularly this here, this is wrong, right? You have to have a round bracket around the 0 because this never really touches the, like you don't get to x is equal to 0. You'll actually get an error if you try it. Second trace 1, x is equal to 0 on any logarithmic, it's going to be like, can't do it, right? The good thing about logarithmic is that you don't do any, you know how half-life and doubling time, you have to come up with the points? Logarithmic, we always give you the points. You don't have to come up with that, okay? So that is one, logarithmic is not going to take us as long. Okay, still word problems though. Good to go, let's flip. I need to make sure, that's why I don't even use the textbook really for this unit. They do not, they only have this version of the logarithmic, which is not what the province wants. They want the a plus b natural log of x. So it's just a note, right? Just worth noting. If you want to go through the book, you're gonna have some issues there. What kind is this again? It's been a long time, right? Hey, I'm exponential. Nice to meet you. Nice to meet you too. Right, this is exponential. I just want you to see what this would look like. And so if it's exponential, this is my x. This is my y. Okay. If it's exponential, what do we know right off the bat? 0, is it 0, 10 or 0, 2? I forgot, Mr. Dirksen. It's 0, 2, right? That's a point on there. What will this be, increasing or decreasing? It's greater than 1, right? B is greater than 1, increasing. There's a reason I'm doing this, right? So I'm going to go make sure this graph shows 0, 2, and I'm going to make sure it looks increasing. Boom. That's what that graph would look like. Right next door is the neighbor, which is, it's a logarithmic, right? So we know this. This is logarithmic. We know that a point on there will be what? 0, 2 or 1, 2? Study sheet, right? It's 0, sorry, 1, 2. 1, 2. You know I like highlighters, right? So I'm going to do this. The only time I don't need a highlighter is when I come home. Because that's just, my wife is the highlight of the day. Okay. Just have to put that in there. B is greater B is greater than 0, right? So it's increasing. That's increasing. Hey, what about the 1, Mr. Dirksen? Yeah, those are the nuances you need to navigate, right? When it comes to logarithmic, it's all about positive or negative. When it goes to exponential, it's either greater than 1 or between 0 and 1. Those are nuances you need to be comfortable with. So how are we going to graph this? Well, now this one goes like this, x and y. Mr. Jackson, why do you not go into the negatives here? Because it will never cross the y-axis. So what's a point on there? 1, 2. So 1, 2. I'm going to get you to match graphs by just looking at these specific points and increasing or decreasing, right? So this is 1, 2. And then you're going to not touch the y-axis, right? You're going to go like this through it, and then it's going to go like that. No negatives. Yeah, no negatives on the x. Oh, I messed that up. Yeah, sorry. Erase it. You're paying attention. That's good. I need to redo this. Undo, undo, undo. Let's do this again. 1, 2 up here. Yeah, good call, good call. So that means that I'm going to sneak in here, go through it, and then keep going, curving, and it's a slight. Just make sure it goes up. Right? And so that's the difference here. It's increasing. It's increasing. You want to try one more? I did this. I honestly inserted this last minute because I'm like, you know what? I need to compare them right side by side right now, because otherwise you're going to be like, what's going on? Why are you moving on to logs? We still miss exponential, right? So here we go. You have another function here. You should recognize exponential. You have an exponential section on your study sheet, right? You're going to look it up. Okay. A point on there is 0, 4, right? B is between 0 and 1. Normally, I just tell students, just make sure if it's less than 1, you know it's decreasing, but we never have negatives, right? So B is 0.76, decreasing. Therefore, decreasing, right? And remember, when it comes to exponential, they never cross the x-axis. I'm going to come up, maybe I'll come up with something creative to help you remember that. But 0, 4 is definitely on there. 1, 2, 3, 4. And it's decreasing. So I'm going to, right, you come in here, go through it, and then this is just a general sketch, right? And this is 0, 4. There we go. P of t is this. Notice that I inserted a natural log in there, which shouldn't even worry you. You should not even be worried about it. The only time you have to be worried about it is when you type it into your calculator, okay? There's log and there's natural log. So you need to press the right one or else your answers will be off, right, compared to mine. And so here we go. This is log, right? Logarithmic. I know that a point on there will be 1, 5, correct? 1, 5, not 0, 5. It never touches the y-axis, cannot be. And I know that this is, b is what? B is less than 0, so this is going to be decreasing. So I'm just focusing on this. And let's get this right this time. 1, 5. So 1, I'm going to go 1, 2, 3, 4, 5. I'm going to put it right there. And it's decreasing. So you kind of slightly want to come from the y-axis, go through it, and then just do one of those. The steepness, we don't know. We can't accurately right now, unless obviously we could have used our calculator to come up with more points, but right now this is just a sketch. Okay, so that's how I want you to understand. I'm just gonna do this again. And on the other side here, I'm gonna highlight the 4 and the 4. And there we have it. I think I'm just gonna stop here and just ask you to do the following. Why is this important before we do word problems? Like, why don't we just jump right in? Well, you need to understand, right, when you type it in, how am I going to predict, how am I going to adjust my window? Oh, it's decreasing. Like, if you know all of these things, you can predict, where do I need to increase my window to? Oh, X max, right? Oh, it's going to go down, so Y min, right? Stuff like that. Let's keep going. So I'm going to ask you to try pages 35 to 37. And 37 has a match. You see that? Mix and match. I wish I would have put more equations up there, like 10 or so you only have to pick the 4. But in this case, you have 4 equations and they match. One matches each graph, okay? And you're like, wait a minute, that's a lot of graphing. These actually don't take a whole lot of time, but look at what I did. I mixed up logarithmic with exponential. Like, I throw everything in there. So you're not just doing logs, 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 you're doing both. Another warning, I have a feeling that some of these values are not going to work out. So if it doesn't work out, just move on, right? Like, I'm asking you if x is equal to -4, I know already this one isn't going to work. Would you be able to tell me why? You never crossed the y-axis, so this is a copy-paste error, right? I went back to exponential, I copied a bunch of those, and I forgot to change this. So focus more on everything else. I mean, this one will work. I know this one, y is equal to 40 will work. So the ones you can figure out, do them. I will try my best to key this. However, you only have so much time, right? If you're like, you know what, I think I get this, I'd rather spend some more time with the word problems that Mr. Dirksen talked about, like all those regressions types of things. I would say do more of that than this. Okay? Yeah, I'm going to stop this here and